Okay, so we were in the azimuthal quantum number, right? Okay, so azimuthal quantum number means it is denoted by L, as I told. Okay, and its value, the value of L does depend on what? The value of L does depend on the value of n. The value of L does depend on the value of n. It starts from what I told. It starts from 0 and it ends at n minus 1. It starts from 0 and it ends at n minus 1. Okay. So depending on that, the different values of L can be there. Now, what is the significance of L? The significance of L is it tells us about the space surrounding the nucleus, so where the electron, the probability of finding the electron is maximum, which we call orbit, right? So it talks such, it just gives us the idea about the orbit. Now there can be 4 different values of L. I should not say 4, it can be. There are 4 different values of L we are going to use, because that is going to solve the purpose till now whatever elements are discovered. Okay, if furthermore more elements are discovered, we can use more number of values of L, but at this moment if we know this 4, that is fine. Okay, so there are 4 values, possible values. One is 0, one is 1, one is 2, one is 3. Okay, 4 different values are there. As I told, they are just telling us about the shape. Okay, and those are called orbits. Those are called orbits. If the value of L is 0, if the value of L is 0, the shape of the space surrounding the nucleus, where the probability of finding the electron is maximum, is nothing but spherical. And that orbit is written as S orbit, small s. Okay, S orbit. Clear? So if L is equal to 0, we are talking of S orbit. Okay, we'll come to this in detail. First, to understand what these numbers are significant. What is the significance of this number? Then we'll come to that in detail. Okay, with the quantum numbers. If the value of 1, so it is spherical. I'm just drawing it like this. It's a sphere. It's a sphere, not a circle. It's a sphere. You can understand that it's a sphere, just like a ball. Okay, where the probability of finding. So within that ball, anywhere the electron can be there, if it is present in the S orbit. Okay. If it is 1, if the value of L is equal to 1, then the shape of this is dumbbelled. Okay, all of us know what is the shape of dumbbell. It's like this. Okay, it's like this. This is the nucleus, and the electron can be anywhere here. You know, all of us do this dumbbell. In the gym we do it, right? The dumbbell. The shape of this is dumbbell shaped. Okay, then if L and this is denoted by, or this particular orbit is called P orbit. This is called P orbit. Okay. If it is spherical in shape, we call it S. If it is dumbbell in shape, we call it P. And who is determining that? It is all determined by the value of L. If it is 2, the shape is double dumbbell. The shape is double dumbbell. 2 dumbbells are there, like this. 2 dumbbells are there, like this. 2 dumbbells. Okay, 2 dumbbells, double dumbbell. That is double dumbbell, and that particular orbit is called D orbit. So first one is S, then is P, then is D. Who is determining that? It is all determined by the value of L. The value of L. Okay, and the last one is 3. If the value of L is 3, in our syllabus the shape is not there because the shape is very complicated. So we will say it also, that one, that very complicated shape, and this is called F orbitals. So how many orbitals are there? How many orbitals are possible? There are 4 orbitals possible, which can explain every atom till date we know. What are these 4 orbitals? S orbital, P orbital, D orbital, and F orbital. Now simultaneously I am writing it over here, the quantum numbers. Okay, see, first quantum number we had, and you are also going to write with me. Please, you are doing with me also. It's not that I am only doing. This 2 we know now. N we know, L we know, N we know, L we know. Okay, I am going to do it for 3, you are going to do it for 5. Okay, you are going to do it for 5. If not now, afterwards you will complete it for 5. Okay, then you will see the video again, and again you will see the note. Everything is there in the note, but first you should do with me. I told the value of n, possible values of n is 1, the possible values of n is 2, the possible values of n is 3. As I told, I am doing for 3 only. You are going to do for 5. You are going to do for 5. Okay, for 5 also. Now for n is equal to 1. What are the possible values of L? The possible values of L is only 0. Did you understand that? 0 means why 0? Because it starts from 0 and ends at n minus 1. So first you find out what is n minus 1. N minus 1 is nothing but 1 minus 1, that is 0. So that means it starts from 0, it ends at 0, that means the value is 0 only. If n is equal to 2, if the value of n is 2, then what are the possible values of n? L, it ends at 2 minus 1. 2 minus 1 means 1, it ends at 1, but it starts from where? It starts from 0. So it can have values 0 and 1. It can have values 0 and 1. If n is equal to 3, now hope you understood that. What are the possible values of L? The possible values of L are 0, 1 and 2, because n is equal to 1 means n minus 1 should be 2. So starting from 0 and ending at 2, that means 0, 1 and 2. These are the possible values. Okay. So if I just write 1, 0, what can you say by these numbers? Just try to understand this. What is this? This is n and this is L, as like pin numbers. What this n is saying? That first level. N is saying the level or the shell. That means we are talking of an electron which is present in the first shell. First shell. Okay, for you shell. Fine, chalo. At this moment shell. First shell. Which orbit? 0 is what? 0 is s orbit. So it is present. If I write only 1, 0, I am talking of something, some electron which is present at first shell and s orbit. If I talk something like this, 2, 1, what does it mean? It is present at the second shell. It is present at the second shell, and which orbit? 1 is indicating what? 1 is indicating p orbit. Okay? How they are differing from each other? They are differing from each other by their shapes. Just they are differing from each other by their shapes. So it is, if I write 2, 1, so each number, as I told, each number is indicating some some significance is there, indicating something of the atom. Okay. If I write suppose 3, 0, what can you understand from there? We can understand that it is the electron is present in the third shell, and which orbit? 0 means s orbit. Okay. If I write 3, 2, what does it indicate? Third shell, and 2 means what? D orbit. 2 means D orbit. Okay. So that I already told you. So please understand that n is telling us about the shell. L, as I told, L ka value can be 0, 1, 2 and 3. If L is equal to 0, it is s orbital or s orbit. You can say orbit at this moment. Okay. 1, it is P. 2, it is D. 3, it is F. Okay. These are the different orbits, and they are differentiated from each other just by the shape. Okay, their shapes are different. Fine. The next quantum number, please understand it, and then you will do it. As I told, you will do it. The next quantum number is M, magnetic quantum number. The third quantum number is M, that is magnetic quantum number. The third one is magnetic quantum number. Okay, and that is denoted by M. The value of L we saw depends on the value of S, right? Sorry, the value of L depends on the value of N. We saw this. The value of M, same way, the value of M I am writing here, the value of M will depend on the value of L. the value of m will depend on the value of L. It starts from, first let us know the value, then we will know the significance. Okay, it starts from minus L. It starts from minus L, it goes on and it ends at plus L. Minus L starts from minus L, it goes on, then it ends at plus L. So if L is equal to 0, it starts from minus 0, ends at plus 0, that means only one possibility and that possibility is 0. Yes? Okay? So if L is equal to 0, the possibility is 0. Fine. But if L is equal to 1, what are the possibilities? It starts from minus 1 and ends at plus 1. So the possibilities are minus 1, then obviously 0, then plus 1. Yes, these are the possibilities when L is equal to 1. Okay, same way here the third shell, if L is equal to 0, the value of m is 0 because it only depends on the value of L. It does not depend on the value of n. Forget about n. The value of m depends on the value of L. It starts from minus L and it ends at plus L. Very simple. Understand it. Very simple. Just understand it and do it. But today only do it. Okay. If it is 1, what are the possibilities? Minus 1, 0 and plus 1. Right? If it is 2, if the value of L is 2, what are the possibilities? Minus 2, minus 1, 0, plus 1 and plus 2. Yes? If it is 3, somewhere it will come 3 also, right? What are the possibilities? Minus 3, minus 2, minus 1, 0, plus 1, plus 2 and plus 3. As I told, I have done only up to 3, n is equal to 3. But you are going to do up to 5. Up to 5. Please, you have to do it. Okay? Now we are coming to, okay, fine, we got the numbers. Now what does these numbers indicate? Now, till now I told you 1, 0. I told you 1, 0, you could tell me the meaning of this. You could say that 1 means the electron is present in the first shell. 0 means it is present in the s orbit. So first shell, s orbit, it is present. If I say 2, 1, you can say it's present in second shell and in the p orbit. You can say it. Okay. Now I will add another number. As in the pin numbers I told one after another, just like that I am adding another number now. Okay. And that number is m. What does it indicate? It indicates, okay, try to understand. Now spherical. If it is, this is the nucleus, please understand it. Okay. This is the nucleus. This is the nucleus and this is the sphere. This is the sphere. You can understand that. This is the sphere. Means S orbit. We are talking of S orbit. Please understand it. Again and again I am saying it. Understand it. The nucleus is there, a sphere is there. So nucleus is at the center and the sphere is there surrounding the nucleus. Obviously, if it is spherical, it does not have any sides rather. Okay, it is not that it is directed in x-axis or y-axis or z-axis because every side it is same only. Okay, so it is not, showing any direction. The spherical orbit does not show any direction. But if it is a dumbbell, suppose this is the dumbbell. This is the dumbbell. Okay, the finger I am pointing out is the middle point of the dumbbell and this is one side of the dumbbell. This is the other side of the dumbbell. Fine. It is a dumbbell. Fine. We know that L is equal to 1 means it is dumbbell, p orbital. Okay. Now if L is equal to 1, then there are 3 possible values of what? There are 3 possible values of m. This m is indicating the direction or the orientation of the orbit. In which direction the dumbbell is there? Dumbbell is like this or like this or like this. Kaise hai? We don't know. That is determined by what? That is determined by the value of m. That is determined by the value of m. Okay. So L is equal to 1 means m can have -1, 0 and 1. That means p orbitals can be of 3 types. P p orbital or p orbit can be of three types, and how they will vary from each other? They will vary from each other by the direction. By the direction. One is directed by -1, m is equal to -1. One is directed by 0 when m is equal to 0, and one is directed by +1. Okay. Now three directions of three p orbitals present in one shell, in our shell, are px. Px means it's oriented along x-axis. Suppose if I draw x-axis, y-axis and z-axis. Suppose this is x, this is y, this is z, perpendicular to each other. The px, this is the nucleus. This origin is the nucleus. The px will be like this. In this direction I wrote x-axis, so px will be like this. Okay, py will be like this. Right? Pz will be like this. Px is like this if this is the x-axis. Py is like this if this is the y-axis. Pz is like this if this is the z-axis. Okay? So how they are varying? If it is present in px, the electron must be present somewhere around here. If it is pz, the electron will be present somewhere around here. Okay, now who is indicating what? -1 is indicating what, 0 is indicating what, +1 is indicating what. In that, I will come to the reason for that afterwards, okay, maybe in the next chapter, okay, not now. At this moment, I am just telling it, if it is 0, if the value of m is 0, if the value of m is 0, by convention, there is no logic, by convention, this is taken as z-axis because it is an internuclear axis. I am using the term, you want to understand that, next chapter you will understand this, okay? Because it is an internuclear axis. So if m is equal to 0, we are talking of z, the p orbital directed or oriented in the z-axis. If m is equal to -1 or +1, it can be either x or y. You can write in case of -1 x, in case of +1 y, or vice versa, -1 y, +1 x. That doesn't matter. They don't have any exact value. Now, if I write these three numbers, you tell me what is the meaning of that. 3, 1, 0. I wrote three quantum numbers now. N, L, M. What does this N indicating? That we are talking of an orbit which is present in the third shell. Third shell. What is third shell? I am still saying shell, but you know what is shell? Shell is nothing but third level of energy. Clear? Okay. If it is 1, the shape of that orbit is dumbbell. The shape of that orbit is dumbbelled, and that is nothing but p orbit. So third shell p orbit. Now that dumbbell is directed in which direction? The dumbbell is oriented in which direction? The value of 0 is indicating that it is oriented in the z-axis. It is oriented in the z-axis. So you can say everything about that particular orbit, right? You can say in which energy level it is present, what is the shape of it, and how is it directed. Clear? Now, if L is equal to 2, tell me, if L is equal to 2, here I have done, if L is equal to 2, what are the possibilities of M? The possibilities of M is -2, -1, 0, +1, +2. So 5 possibilities are there. That means L is equal to 2 means d orbital. So there can be 5 different d orbitals oriented in 5 different directions. Clear? Okay. So let me write it. S orbital, only one can be possible because no direction. P orbital, maximum how many can be possible? 3 can be possible in 3 directions, x, y and z. D orbitals, I am not saying at this moment the exact directions, but next class only we will talk about that. Okay, but at this moment we just know that d orbital, how many are possible according to their direction? The 5 of them are possible. Clear? And F orbital means L is equal to 3. If L is equal to 3, tell me the possible values of M. -3, 1, -2, 2, -1, 3, 0, 4, +1, 5, plus 2, 6, plus 3, 7. So how many orbitals are possible? F orbitals, there are 7 possibilities. There are 7 possibilities. Okay. So these are the possibilities of the number of orbitals present in a particular shell or particular energy level. Okay, depending on their orientation. So by this set of, I just at this moment some other example had come to my mind. Now I'm just telling it. You can understand that. Okay, that by this set of 3 quantum, other example means don't write it anywhere. Okay, this is just for your understanding. I'm telling all this nonsense example. Just pin code I told, then this thing, something else also just struck in my mind. Now I will tell that also. But before that, let me tell that 3 numbers, any 3 numbers. Suppose I am writing 3, 2, 1. If I say 3, 2, 1, you can tell about the orbital, right? If I say somewhere 3, 2, 1, what can you say? That we are talking of third shell or third energy level. 2 means what? 2 means what? 2 means it's d orbital, right? 2 means d orbital, third shell d orbital, and 1 means one of the d orbitals out of 5, which is particularly directed in a particular direction, which I didn't say till now. But you will come to know in due course of time, maybe in the next class only. Okay? So you can tell everything about the orbital by these 3 quantum numbers. Clear? So we can reach to the orbital. Now I am telling orbital, orbit से orbital हो गया. ऑर्बिट कहां तक था? जब तक हम लोग डायरेक्शन मेंशन नहीं किया था. whenever we mentioned the direction, I am telling them as orbital. Your concept was limited till shell only, right? When you were in class 10, your concept was limited in shell. Now from shell we had come to orbit, from orbit we had come to orbital, right? Okay, shell, orbit, orbital. Clear? Okay, so fine. Now try to understand. Just this is again the same thing that has come in my mind. I'm just telling it. Suppose we are having an apartment, and you want to go to some flat. Somebody's flat. Okay. So first thing you have to know, you know the apartment, fine. First thing you have to know that which floor. First thing you must know which floor. There are so many floors, and so many different types of flats. कोई 2 BHK है, कोई 3 BHK है, कोई 1 BHK है, whatever. Okay, there are so many types of flats are there. Okay, so to reach to that particular person, first thing you have to know what? You have to know the floor. You have to know the floor of that person where he is staying. Okay, so suppose you know that the floor is 3. Floor is 3 means you are moving to the third floor. You entered over here. You are not going neither here nor here. You are using the lift and going to the second floor. Third floor means second floor. Okay, so second floor means you are entering over here. Yes. Okay, done. Very good. Now you know that he is staying in 1 BHK. 1 BHK. Okay. Now there are 2 1 BHK. This is 1 BHK and this is 1 BHK. So that is suppose opposite to each other. So you entered to that particular position where 1 BHK flats are there. So you entered there 1 BHK position, or suppose this 2 only I am telling. These 2 are 1 BHK. First 2 are 1 BHK. So you know now. So second thing you went. So first thing you went to the floor. Second thing you went to the particular area. Now you know that the person who is staying, you have to know the flat number. Suppose the flat number 1 and 2. Flat number is 1. Flat number 1 means you know that's in the left hand side. Flat number 2 means that in the right hand side. So you know flat number 1, you entered to his flat. You will never go anywhere. For that you have to know 3 things, right? 1, the floor. Second, the flat type. And third, the flat number. If you know this, you can enter exactly to that particular position. Okay? Just like that, to enter in a particular orbital, to talk about a particular orbital, how many numbers do we need? How many quantum numbers do we need? We need only 3 quantum numbers. Principal, which will tell that which shell it is there or which level it is there. Azimuthal, which will tell that what is the shape of that orbit. Clear? In that particular shell, which orbit? Clear? Third, magnetic, which will tell that in that orbit, out of that orbit, which orbit we should go, whether we should go in the x direction or y direction or z direction in case of p orbital. In case of d orbital, there are 5 different directions. In case of f orbital, there are 7 different directions. Okay, which orbital will go, that will be told or that will be said by 3 quantum numbers. Okay, so we reached to the flat. Now each flat, this apartment is such that, please understand it, this apartment is such that, whatever is coming in my mind I am saying, this apartment is such that in each flat there are 2 persons. There are maximum 2 persons. Okay, more than 2 persons are not allowed in any flat. Fine. Now obviously 2 persons are staying in a flat must be differing from each other. They cannot be same. Now suppose Ram is staying and Sham is staying. Ram and Sham are staying in one flat. You want to meet Ram. So you must know the difference between Ram and Sham. You went to the flat. You reached to this flat. In this flat now Ram and Sham are staying. Now you want to meet Ram, not Sham. So you must know something about Ram. There must be some difference between Ram and Sham. You must know that. Then only you can, just by seeing the 2 persons only you can say, yes Ram, I want to talk to you. Suppose Ram is fair and Sham is dark. Suppose the difference. Or Ram is short, Sham is tall. Whatever. Some difference will be there. So you saw 2 persons and just by seeing 2 persons you can very easily identify that this is Ram and this is Sham. This Ram and Sham are nothing but electrons. This Ram and Sham are nothing but electrons. Okay? So in one orbital which I talked about, which is indicated by the set of 3 numbers, maximum in one flat is an orbital. Okay? Maximum 2 electrons can be present. Maximum 2 electrons can present in one orbital. In one orbital, maximum 2 electrons can be present. Maximum. Okay? Out of that, one, now you know, electrons just like Earth, you must know this. Okay? You all know that electrons are revolving like this. You don't know that electrons are also revolving like this in its own axis. Okay? Just like Earth rotates in its own axis. You know that? As well as Earth is rotating surrounding the Sun. Exactly that, like that, electron is rotating in its own axis and electron is rotating surrounding the nucleus. Not in a circular path, by the way. Not in a circular path. Rotating means traveling. Where in that particular space it is traveling. Okay? But not in a circular path. Okay? Now how these 2 electrons present in same orbital is varying? They are varying according to their spins in its own axis. If one of them is rotating in the clockwise direction, the other one is rotating in the anti-clockwise direction. If one of them is rotating in the clockwise direction, the other one is rotating in the anti-clockwise direction. And that is denoted by the 4th quantum number, which is called spin quantum number. So spin quantum number, which is denoted by S. In each orbital, I told, each orbital there can be 2 electrons, one having positive, the clockwise rotation, another one will having, rotation means spin, not rotation, spin in its own axis. Okay, clockwise spin, and another one will having anti-clockwise spin. The one having clockwise spin, so S can have 2 values. The spin quantum number can have 2 values. If it is rotating clockwise, we will denote it by half, plus half, and if it is rotating anti-clockwise, we will denote it by minus half. I told for each orbit there are 2 electrons present. Now see it over here. For each orbit, please understand it. For each orbit, 1, 0, 0 is an each orbital. Now 3 quantum numbers are defining one orbital. 1, 0, 0 is an orbital. For this, there can be 2 electrons, spin quantum number. One is having minus half, another one is having plus half. So I want to meet Sham. its quantum number is 1, 0, 0 plus of. And what will be the quantum number of RAM? 1, 0, 0 minus of, because they are varying by how? They are varying only by their spins. So at least by one quantum number they are varying. Next one you see, 2, 0, 0 is an orbital. For that, there will be 1 plus of, 1 minus of. For 2, 1 minus 1, please understand it, 2, 1 minus 1, there will be 1 plus of, 1 minus of. For 2, 1, 0, there will be 1 plus of, 1 minus of. For 2, 1, 1, there will be 1 plus of, 1 minus of. Yes? You will complete this table till 5. Hope you understood this. Hope all of you understood the concept of quantum numbers.